Hi everyone, I am Pinjia He. In this talk, I will introduce our work testing machine translation via referential transparency. Machine translation has been widely used in our daily lives. Nowadays, we have a lot of machine translation systems, such as Google Translate and Bing Microsoft Translator. Machine translation has also been used in industry. For example, eBay is a company that is selling things to more than 20 countries in the world. And these countries are using different languages. eBay has more than 800 million listings. Each of them has around 300 words. And eBay needs to provide the translations for all of them. And this is not an easy job. eBay estimates that if they have 1,000 translators, using 5 years, they will be able to finish 60 million listings only for one language setting. Not to mention that a lot of those listings are being updated frequently. Thus, eBay heavily relies on machine translation. Nowadays, machine translation can already return high-quality results. However, sometimes they can also return incorrect translations. And here is an example. A few years ago, in the Winter Olympic Games in Korea, the Norwegian team intended to order 1,500 eggs for their athletes, so they asked Google Translate for help. But at the end, they received a full truck of eggs. And they find out that this was caused by a translation error, that their text was translated to 15,000 raw eggs. Thus, we can see that incorrect translations can lead to misunderstanding, unpleasant experience, or even potential financial loss. And so how to get rid of this kind of translation errors and make the translation software more robust? What eBay is doing is heavily rely on regular expression. For example, this is a translation that translates the plural form of an acronym in English to French. And as a background knowledge, the plural form of an acronym should not have an X at the end of the acronym in French. However, for machine translators, sometimes they will make this error. So to detect this kind of grammar errors, eBay uses this regular expression and to automatically extract all those potential errors that has an X at the end of the acronym. We can see that this approach is highly limited by the domain knowledge of developers. And because they need to write a lot of those rules, it is also very labor intensive. So we were thinking, is it possible for us to design some fully automated approach that can report general translation errors? And this is what we have done in this work. What we have done is, using only 200 source sentences without any label, we found 265 erroneous translations in Google Translate and Bing Microsoft Translator. Our proposed technique is called RTI, that is short for testing via referentially transparent input. Its core idea is referentially transparent tests should have similar translations when used in different contexts. It was inspired by the concept in functional programming. In functional programming, we say that a function is referentially transparent if the return value is the same for a given input, even if it is used in different contexts. For example, assume we have a function square that returns the square of the input, and we give 2 as the input, we got 4, and after a few minutes, we got 4, and after another few minutes, we still got 4. So the return value is the same for a given input when it is called in different contexts. And here, for example, is the time. Another is the time function, which returns the timestamp. So we call it in different contexts, it will return different results. So time is not referentially transparent. At that time, we were thinking, is it possible for us to find something similar in natural language? And in our work, we define the RTI in natural language as a noun phrase within a specific length range. And we extract those RTI from a random text. For example, here, assume we have this Holmes in a movie based on bad blood. We want to extract an RTI. We first use a constituency parser to get a tree form structure. And then we find the noun phrases in the tree, and we select those within a specific length range. For example, here, we will select this noun phrase, a movie based on bad blood. And this RTI will be paired with the original text, the containing text, to generate an RTI pair. And then we collect the translations from the software we want to test. And now, based on our idea, we compare the translations of the RTI in these two phrases and see whether they are similar or whether they are the same. And in this example, the translation for RTI in these two phrases are different by 3 characters. So we can say by distance 3. And if the distance is larger than the threshold, it will be reported as a suspicious issue. And after getting this issue, developer can find out that the first one was not translated correctly. It was translated to Holmes' blood becomes bad based on a movie. Our approach can report diverse kinds of translation errors, including under-translation, over-translation, word phrase mistranslation, incorrect modification, and unclear logic. And I will give you 2 examples. First, under-translation means that some parts of the source sentence was not translated in the target sentence. Here, the almost anxiety-provoking magnitude of data was translated by Google to the most anxiety-provoking data. So the magnitude of was not translated, leading to an under-translation error. Unclear logic means that all parts, all phrases or words was correctly translated, but the whole logic of the sentence is incorrect. For example, here, approval on 2 separate occasions was translated to approve 2 separate occasions, leading to an unclear logic error. Next, let's talk about the precision of our approach, which means the percentage of issues containing errors among all those reported issues. And this is one report issue. Assume we have 5 reported issues. If 3 of them contains real error, we will say that the precision is 60%. Compared with the existing approaches, we have the highest precision, which is around 80% for all those cases. The last question is, are the erroneous translations found by RTI different? The answer is yes. We can see that in this Venn diagram, we show the different erroneous translations reported by the different approaches. We can see that there's only a very small overlap in the middle, and RTI can report more erroneous translations than others. Last but not least, we have released all the source codes in this paper in a repository on GitHub. Feel free to take a look. Thank you.
Hello, everyone, and welcome to the last talk in this session. Thank you, Pinja, for your talk. If anybody has questions, as usual, please type them in the chat. And I would like to start with a question. So language translation is a very difficult problem, and you know that very well. One of the main problems, like you said, is context. Context is a big problem. The Venn diagram that you showed on slide 19 shows that RTI detects a large number of different, but there are also many that it does not detect, right? So I'm just wondering, like, how do you, in real practice, how do you expect your approach to be used? Do you expect it to be used in conjunction with other methods? Like, what do you recommend?
Yeah, I will expect, thanks for your question. And I would expect the approach to be used like in conjunction with others. So RTI is very good at detecting erroneous translations for phrases. And for the other approaches, they are better on like detecting errors in sentences. So in practice, we can use them together.
Okay. There's a question from the audience from Leima. When the mistranslation is detected and found, how can your technique be used for model enhancement, or how could it be used by the developer?
Yeah, this is a great question. So it could be used like in multiple ways. Like first, our approach, we report a line of suspicious issues. So for those developers, they can get this line of reported ones. So if they find out that some of them are like urgent one or very critical one, they can just hard-coded them in their translator. And another one is for the others, you could use them to fine-tune your model, and that will also help to improve your model.
Okay. So while other questions come in, I can ask another question. So you said earlier that you would expect your model to be used in conjunction with other models. So would you expect performance to be a concern? Because now it's yet another diagnostic or another technique that would have to be used. Is this a concern at all? Like, how fast is RTI?
Yeah, thanks for your question. Like our approach is running pretty fast. So we have 4 sets of experiments, like 100 sentences for Google and etc. So for each of them, we can like finish the processing within 1 minute.
Okay, that's not bad. Okay, let's see if more questions come in. Let me remind people to ask their questions.
Sure, thanks.
Okay, so from a research perspective, what was the most difficult aspect of your research in this particular project?
Thanks for the question. I think in this project, the most difficult step was to find RTIs that like a piece of text that should remain like similar or invariant translations in different contexts. So that's the most difficult part, because usually we will have multiple translations for the same source phrase or sentence, and yeah, that's the most difficult part. And we try to use RTI, that is the noun phrase with a specific length range, to tackle this question. Tackle this challenge.
Okay, I see. That makes sense. So there's a question, but I'm not sure if it's regarding these types of if it's related specifically to this presentation. Let me ask for clarification from Ashkan. If you could clarify a little bit your question. Are you talking about testing in particular translation systems? And in the meantime, a question from Lema. Do you find some that if the deep learning do you think there are any relationship? Is there any relationship with the deep learning model architecture and the detected issues? I believe that is the question. What is the relationship with the model architecture and the types of issues that are being detected by your model?
Yeah, thanks. For the first one, work that has been done in ML or NLP community regarding testing systems. So what they have mainly done is kind of adversarial examples generations, and the main difference between them and us is that in most of their approaches, what they would are sentences that either like syntactically or semantically incorrect. For example, like I like basketball, you can generate a sentence called like I basketball like, and that may cause some translation. So that's mainly done in NLP community. And what we focus on is like to generate syntactically and semantically correct sentence. So what we generate is sentences like I like football or I like volleyball, those kind of sentences.
Okay. And Lema added some clarification to the question. Are there specific insights on why a model architecture would fail at a particular case? I imagine this is in the context of language translation.
Yeah. Actually, we haven't gone into the depth to like explore the internal details of the models, but I have like saw some papers in NLP field. They try to build a connection between the internal like parameters and a specific kind of translation error. Yeah, if you're interested in, we can discuss later, and I can share with you some links.
Okay, so I guess the question in general, there's some discussion around this, is do you think that RTI could be used on for other NLP tasks?
Yeah, this is a
so the answer is yes. Okay.
Yeah, the answer is yes. For example, you can use in face recognition. So our core idea is the text should remain the same context, like when it's used in different sentences. So it's like you can also find a similar thing in speech recognition, all this stuff that are like generating text from other things.
Okay. Let's see if there are any other questions. Yeah, the other question is related to the same thing. Okay, let's see if there are any other questions. A couple more minutes. Okay. Okay. So Pinja, I think we've run out of questions. So thank you very much for your time. People are welcome to stay and talk to Pinja or move to the discussion room. And if not, see you later during the conference. Hope to see you all. Take care.
Thank you. Thank you all. Your question maybe is the difference between the works in NLP community and in SE community, right? Yeah. So what like people in NLP feel like mostly are doing is try to generate adversarial examples. So most of the sentences or like examples reported by them are actually syntactically or semantically incorrect. And what we have